Andrew here. In this video, I'm going to discuss our comparative statistical tests, um, and this will be part one of a series so that no video is too long for uploading purposes. I'd like to start off by considering a given phenomenon in research. If you look at the left, I have a picture of someone slicing through an onion. You can think about an onion. We could look at the onion from the outside, describe its shape, its color. We could slice through the onion. We could compare the different levels or layers of the onion to see how they're different. And we could even get into the inner core of the onion and see how that is compared to the rest of the onion, its exterior. Um, and then we would really maybe understand what an onion's really like. The picture below it on the left is something I'd like you to consider again is kind of the same way of thinking, is that we have some phenomenon and we can peel away the different layers and understand that layer and then go on to the next layer and finally get to the innermost layer of a phenomenon or the innermost workings of a phenomenon. And maybe at that point we really start to understand it. So, for example, consider we have a new phenomenon that something that's come up since the pandemic called vaccine fatigue. It's described as an inaction towards vaccine information and recommendations. It's thought to be due to perceived burnout and burden. So consider that this is a new phenomenon. We really don't know much about it. How would we go studying? Well, we don't know what variables are involved in this given phenomenon. So first we have to go out and look for those variables. So we might start off with a qualitative research study. In this study, we make observations, we ask open-ended questions. We have a group maybe of people who have been identified as having vaccine fatigue. We have another group that does not have vaccine fatigue. And we ask them open-ended questions. How many vaccines have you had? Have you ever been sick? Maybe we find out what their ages are. If they've had relatives close to them that got the vaccine and got sick, and others who didn't get the vaccine and did get sick, we asked them to tell us about their lived experiences. From that, we'd have a narrative, paragraphs, pages of text, nothing we can measure, but we might be able to start identifying themes within those paragraphs, and those themes could become variables. And maybe we do find that as a variable, that it seems like the people who have vaccine fatigue have had experiences where people got the vaccine, didn't, and still got sick, and others who didn't get the vaccine and didn't get sick, and those who don't have vaccine fatigue, maybe their experience is completely different. So now we have variables we can measure, and when we have variables in a phenomenon we can measure, we want to use a quantitative research process. And what I've listed here are the 5 categories I think of when I think of quantitative research. This all has to do with different levels of questions we're asking, and as we go down this level, this list and these levels, we get a stronger and stronger type of research study. So we start off with descriptive, then we move to correlation, comparative, which is what we're discussing in this session. Then we can get into regression and epidemiology studies. So this is another way of looking at this, qualitative research. We start off with observations, open-ended questions. From this, we try to glean variables. Then I have my 5 categories of questions and research studies. In descriptives, we ask how much type questions about one variable. Correlations, we ask if 2 variables are related, associated, or correlated. So that might come up that when we're working with collecting descriptive data, we start to make observations, such as it seems like the people who have had close relatives who got the vaccine and still got sick have more or higher levels of this vaccine fatigue. So we do a correlation study, and we find out, yes, indeed, these 2 things maybe are related. That's not the type of information that I think we can go out and actually put into practice, because there might be other variables involved. But what we can do with such a correlational studies, we can get into comparative studies. In comparative studies, we want to know about comparing conditions of an independent variable. We want to know about differences. We want to know if one group has an increase in the phenomenon, such as vaccine fatigue. Maybe another group has a decreased level of vaccine fatigue. We might want to give out education, for example. We have a group with vaccine fatigue. We might want to try different types of education. For one group, we do one-on-one interactions. Another group, maybe we do an online seminar, a video that we want them to watch. A third group, maybe we meet with them as a group. And maybe from these three different types of education, we see if any of these has a way of decreasing vaccine fatigue more so than the others. That would be a comparative type study. In regression, we get to the point where we can actually predict the actual value of a dependent variable. So, for example, maybe we understand this phenomenon so well that we can get some information from a person. We can get maybe their gender, their age, the number of close relatives they had who got COVID even though they were vaccinated. We can put those measures of those variables into a formula, and from that, without even asking, we will know, we will be able to predict if this person does have vaccine fatigue or not. It's incredibly powerful to have some variables that we can know their metrics and be able to predict an outcome or a dependent variable. Beyond that, at the highest level, from my point of view, is epidemiology studies. And these are questions about rates, probabilities, risk, likelihood. We might find out that from a study at this level, that someone who's had a very close relative who got the vaccine but still got COVID might be at, say, 4 times greater risk of developing vaccine fatigue than someone who did not have that experience. So each category leads to a different type of each category has a different type of question, leads to a different type of answer, and gets more and more information, stronger and stronger evidence for us in understanding a phenomenon. This is part of my algorithm. I'll bring it back up in the last part of this session, but you could think of it this way, that we're going down, we have a question, we're going down this list to find out where that question best fits in. So if we have something like, what is the level of job satisfaction in nurses? That's a descriptive statistic. Here it might be, what's the level of vaccine fatigue in males in Louisiana? That would be a descriptive type question. Once we have that kind of information, we get into correlations, where we start to see relationships, associations, correlations between variables. It might be that in doing our descriptive study, we noticed that it seems like maybe the older one is, the higher their level of vaccine fatigue, or the younger they are, the higher the level of vaccine fatigue they have. So we could do such a study and see if two variables are related or not related. From that, again, I would suggest that we don't go out and use that information, but rather that serves as a basis for a higher level study, and the next higher level study would be the comparative group. Here, our kind of question is there a difference in job satisfaction between, say, BSN RNs and NPs? Or maybe is there a difference in vaccine fatigue between males and females? That's a comparative type question. It asks about differences. Regressions, again, get into prediction. So we might have, as an example, a question such as, are gender, age, and years of experience predictors of job satisfaction in nurses? For our vaccine fatigue, it might be almost something very similar. Are gender, age, and number of vaccines someone has been given over the years, are those predictors of vaccine fatigue? And finally, again, we have the epidemiology group, where we're looking at risk, odds, probability, likelihood, survival rates, incident rates. Anytime we're studying a rate or a difference in rate, comparing rates, or what is the rate of something for me, it all falls into this category of epidemiology tests, which we'll cover in another class. I wanted to review real quickly our different levels of measurement, and the only reason why we really want to know what level of measurement we're using for a given variable is this will change or determine the test we use. And we'll get back to this in a few minutes, but we really want to be very clear on these different levels. Nominal means named. These are named groups with no kind of hierarchy or order. Examples would be one's gender, race, ethnicity, political party affiliation, country of birth, primary language. If we group patients by their eye color, that all would be nominal data. If we ask somebody if they have an illness or a diagnosis or not, that's also nominal data. Anytime it's a yes or no, if you could narrow a question down to either yes or no, that will also be nominal data. So, for example, we might have a study and we're looking at the participants' primary language, and we find out that 50%, for 50%, their primary language is English, for 25% it's Spanish, 15% are Mandarin, and 5% are French, and 5% are German. That would be all examples of nominal data. Ordinal data is data where we measure a variable with words, and those words have some order or varying amounts of that variable. So if we ask patients if how satisfied they are with their care at our hospital, and we give them these choices: very dissatisfied, dissatisfied, neutral, satisfied, and very satisfied, that is an example of ordinal data. So it's where we have words with varying amounts of the variable that we use to measure that variable. The problem with ordinal data, by the way, just to be clear, is that we really don't know what the difference is between, say, very dissatisfied and dissatisfied as compared to dissatisfied and neutral. It might be that a patient that would say neutral, it might almost take nothing, one little minor incident, and now they're dissatisfied. Then, say, one incident. But to go from dissatisfied to very dissatisfied, it might take quite a few incidents. So that's the point, is we really don't know the difference between our different words that we use in terms of some kind of metric or actual measure. These are just words that we use to rate that variable. And it's ordinal because they have different amounts of the variable. But again, we don't know if the difference between any two next to each other are the same as the next two. Scale data is where we measure a variable with a number, any kind of number, but just a number. In the past, we've used different terms for this. I'll get to that in a second, that we really want to try to avoid using now. I'm of the opinion that there is a fourth type of data, which I would call a rate. It's a ratio, such as when we're talking about an infection in a population, that maybe we have 10 out of 100 have this infection, or 10 out of 10,000 have this infection. It might be with the percentage of CAUTIs or catheter-associated urinary tract infections that we have in our hospital. Maybe for every 100 days a patient has a catheter, we have 2 infections. And that might be something we want to compare to a national average where there's only 1 per 100 days. So to me, that's different. And the reason why it's different for me is, again, if we have data that's measured at the nominal, ordinal, scale, or rate level, it will lead to us using a different test. These are some of the terms I think that are older. You will see them that I try to avoid using. And the reason why is simply because, for example, categorical data is a mashup of nominal and ordinal data. However, we have different, if we have a variable measured in ordinal data, we will use a different test than if we have it that same variable measured at the nominal level. So for me, I really want to know, is it nominal or ordinal data, because that will lead to a different test, as we will see. In the old days, we used to use these terms. Discrete data was whole numbers, continuous data was data with decimal places, interval data was data where the numbers had equal units of measure, but there was no absolute zero. Then we had ratio data where the data was in equal units of measurement, but we did have an absolute zero. But the problem is, all of these types of data, all of them, are treated exactly the same statistically. The big thing is, as we'll see, we can get a mean. If it's a number, we can obtain a mean. So it really doesn't matter if it's discrete, continuous, interval, ratio, we're going to treat it the same. So now we use a more inclusive term called scale data. And from my point of view, there's no reason to discriminate or to differentiate between these types of data, because we treat them the same statistically. One is no better than the other. Um, anyway, here's some more levels of measurement and central tendency information that we've covered in the past. But just to go through these again, nominal data like country of birth, we might see in a study that we had 20 participants, 10 were born in the United States, 7 in Mexico, 3 in Canada. Here we can't calculate an average or mean, we can't calculate a middlemost score, so all we use is the mode, which is the most frequent response, and here it would be the USA because there are 10 participants that you say that is their country of birth. Next, for ordinal data like patient satisfaction, where we measure our patients as being very dissatisfied, dissatisfied, neutral, satisfied, and very satisfied. Imagine we ran a survey. None of them were very dissatisfied. One was dissatisfied, 2 were neutral, 4 satisfied, and 3 very satisfied. Here again, we can't calculate an average or a mean, and it's simply because we don't know if the difference between somebody being dissatisfied and very dissatisfied is the same as any other difference here, such as between neutral and dissatisfied, as we already mentioned. But we can calculate the middlemost response. So if we put these all in order, we would find the middlemost response is satisfied, 4, because we have 3 who were very satisfied and 3 who were less than satisfied. So we can use that. We can use our middlemost score, or the median, to describe this data. So it would be 4. We can also note the most common response or mode, and here again it would be satisfied. 4 is the most frequent. It is possible to have what's called bimodal data. For example, if we had 4 who were also neutral, so the most frequent response is 4, but it's for satisfied and neutral, that's considered to be bimodal data. Scale data is when we measure a variable using numbers, and here we can calculate the mathematical average or mean. We can also calculate the middlemost score and the most common score. So here's some examples. Imagine that we measure the pain level in 3 patients. We ask the first, do you have pain, yes or no? Some say yes, others say no. What level of data would this be? Nominal, ordinal, or scale? It's nominal data because it's simply yes or no. There's no order or hierarchy here. It's not a number. Anytime we have a yes or no response, does the patient have a diagnosis or not? Yes or no. This is all examples, or these are all examples of nominal data. If we ask a patient to rate their pain using these terms, none, minimal, moderate, severe, or excruciating pain, what level of data would this be? Nominal, ordinal, or scale? It's ordinal data because we're using words that have varying amounts of the variable pain. Finally, we ask a patient, how would you rate your pain on a scale of 0 to 10, with 10 being the highest? What level of data would this be? Nominal, ordinal, or scale? It's scale data because we're using a number. We're forcing a patient to consider a number line, sort of like a ruler, and to quantify their level of pain. It doesn't matter that it's subjective. It doesn't matter that 2 patients, if we could figure it out, have exactly the same amount of pain, but one feels it more than the other. That's immaterial, because when we're assessing a patient for pain, like many other variables, it is a perception. It's their perception. It's not objective, it's subjective, it's what they're experiencing. But if we ask someone to use a number scale like this, that is scale data. What level of measurement are each of these? We measure a patient's depression as having the diagnosis or not. That would be nominal data. We rate the level of patient depression as being mild, moderate, or severe. That would be ordinal data. We rate the level of depression on a scale of 0 to 10. Maybe we have a list of symptoms and we check them off. This patient has 8 of these symptoms. That patient has 6. If we're using some kind of numerical scale, if we provide each patient with some kind of numerical evaluation, that is scale data. Perhaps we're looking at a 5K running race, and we award participants on the basis of several different styles. If we call it finished or non-finished, that would be nominal data. If we give out awards for first, second, and third place, that would be ordinal data. Or if we record the run in time in minutes and seconds, that would be an example of scale data. So this concludes part one of the discussion of comparative statistical tests.